Welcome back. Last video I'd started finally, after 4 years of it sort of intermittently being developed a bit and collecting cobwebs, developing the reciprocating chronometer, which I'm really pleased about because recently I worked out why the AM/PM cam system was overrunning. I was absolutely thrilled to have finally worked it out. So here was another one that's been sitting around for donkey's years. Quite why the spiders don't like that one so much, I don't know. What I've done though, in the last video, is to work out and solve and improve tons and tons of things. It has been so enjoyable. Let's hope it will come to fruition, because the next step is to actually build what I've built, what I've constructed or whatever, put the parts together. Before I do that, I need to clear the decks, so I really must just finish putting these together. I've got them practically all done. I just need to hook the drive belt round the little motor and test it. When I'm happy it works, I will then put the front on, and then they're ready for dispatch, rather than leaving them sitting around being dropped on the floor. I think then I need to get the latest lot of 30 of the gauges, the little decorative gauges that are there for these, or indeed the slightly larger size. I've run out, so before I get some more orders for these, I need to make another 30 of the enclosures. I meant to say, this very morrow I woke up thinking the AM/PM indicator hasn't got some sort of 3D printed drive shaft. How very dare I forget. But what it did have was a counterweight to try and keep pulling over to the left. There we are, you get the idea. There's a counterweight here, and then that flips over and keeps that pushing against the cam that way. Thing is, to do it like that means it's all well and good for me to glue this on and then use the pillar drill to drill a hole through that and the counterweight at the back. But if it was a kit, that is really difficult to do. And equally, I thought, how can I involve the 3D printer in this part of the project? Well, I came up with the idea of extending the engraving on the front. That means that you can line that up very... Oh, hang on, there's the doorbell. That was the postman just delivering this. And I can recommend these because when I've been decorating the inside, the back of that, with some metallic markers, I found that, well, the silver and the black ones didn't really cover very well because they were dissolving the brass paint, whereas Uni-Paint marker is oil based and opaque and all sorts of other stuff. It is brilliant. I had a silver one that I was using, and it turned what was an unpleasant, time consuming job again into a joyful experience because it covered beautifully. It's got a big nib. The base of these gauges is slightly raised, so you can pick out, I'll show you, no I won't because I haven't got any, because they're slightly raised, the design, so you can really easily and joyfully paint over them as long as the paint takes, and this does. So in the end, because the black marker was running out and was starting to dissolve the paint, I got a black version. I can't wait to have another go at making some more. Anywho, back to this. So I realised that doing it like this means that you can glue that on really easily. Oversized hole here, so you don't have to line the holes up really accurately. There will be the 4.1mm hole drilled in this bit first by me, and then it makes it really simple. It also means that you can line this up at the right angle. Because when I was drawing it, I realised I'd lined it up all wrong and had to double check. So it solves several issues in one go, and I even managed to come up with a 3D printed part. It's the cam follower. Look at that. So before it was just a little rod of plastic which I've lost somewhere. Again, how deep to glue it in, getting it straight, getting it out. But now you get your 3D printed bit, prong. I've redesigned it with the hole slightly looser. Push that down. Look at that. It's just fantastic. And then there are the 4 little dimples, so you can just drip a couple of little drips of super glue that'll run underneath and glue it really firmly. I am so pleased with that. Again, as I say, I need to wait until I've actually assembled this to see whether any of it works, but that's half the fun. Now I must stop talking, get on with doing something useful. just started tidying up and found this, and remembered that I meant to mention it. Remember when I got all over clever and decided that if I was going to cut out something such as this on a laser cutter, I would then decide to have that as one colour, this as another, that as another colour, and then cut them all separately, thinking I was being very clever and that it would reduce warpage and distortion. In fact, it had the opposite effect, because every time the plastic was heated and cooled, it would distort a bit. I cut these out the other day, 5mm acrylic, in one go. I mean, look at that. You couldn't make it up. Look at the accuracy. It is unbelievable. I remember wondering a couple of years ago, why has my laser cutter stopped being able to cut beautifully? And it was me, of course, the spanner in the works. That's just amazing. That's under 1mm thick. I think that's about 0.5 millimeters. Oh, it just it brings a tear to my eye. That is so exciting. I'm very pleased with that. They're all working beautifully. I forgot to say, they come either with a lovely battery holder which holds two AA batteries with a built-in switch. One of these gauges will work for days and days and days on a couple of AA batteries. Alternatively, a rather pleasant, you can't really see it because it's in this anti-static film, a rather pleasant voltage regulator chip which will take anything from 4.5 to 12 volts DC and will turn it down to the 3 volts that the motor needs. And it even has a little red light on it. What more could you ask for? As engineering ideas go, this has got to be one of my worst. I need to drill two 3.3mm holes there to then tap to support this onto the base. Until I build a jig or something, I thought, oh no, spirit level, that's not level, but it's just touching the line on the right. I've adjusted it so that is the same. Oh, fantastic. Don't try this at home. I hasten to add, it's not fantastic, it is absolutely appalling. But as long as I keep it that way around, I think I'll be able to drill the holes. I've drilled it down into this hole, which just coincidentally was there for decorative purposes, because it is so much easier when you're tapping plastic to have an exit at the far end for all the swarf to come out. Otherwise it can all get very, very hot and melt all the threads away. I'm going to try and demonstrate the impossible. I have a small receptacle of isopropyl alcohol, which I found is very good for lubricating, cooling, whatever else, and then evaporates and doesn't leave any sort of residue. This is on its lowest speed, going clockwise. I'm going to try and get it lined up with everything. There we are. And as always, when you're tapping in a bit, it's theoretically half a turn if it's metal, and then back, or 1 turn and half a turn, something like that. Anyway, you can see what's happening. And you can also see how the swarf is all coming out of that hole. If the hole wasn't there, it would all be gathering and compressing at the far end of the thread. Oops. Right, that'll do. There we are. So that can accept a 4mm screw, and that will hold it. I'll do the other one. I've also got a plan. The first one telling me how to tap which holes need to be tapped and cleared and all the rest of it, which I'm currently doing. Thank you. It's another day and I was about to start putting the chronograph together, and then I got an order for a ready-made Nemnet Throbwell kitchen timer. So I've unpacked one and I'm going to now assemble it, which is very exciting. Allows me to prevaricate the construction of this even further. Also, I finished all those gauges, spraying them up, and out of 60, 30 large, 30 small, I had 12 or something, weren't quite right, didn't pass muster. So I've had to use some wet and dry, and I'm just spraying those up. Perfection is my watchword. And now I've returned to DVDs, hating Amazon Prime and stuff, because they just keep telling you, oh, this belongs to you, you own this, this is free to you. None of it's free, you pay for everything. And even if you buy lots of movies, they say that are yours, if you stop being a member of Prime, you lose them all. How fabulous. So, DVDs and today's. This is Miss Sloane. Jessica Chastain has been in some amazing films. Brilliant. And I do like that because there's lots of intrigue and things. So, let's get on with it. The other thing that arrived were 6 little gauges. Beautiful things. Look at that. Isn't that lovely? Now it says it's a proper... Let me get it out of the packet. It says it's 300 volts. AC or DC, I think, but that's fine, doesn't mean anything. It just means inside there's a resistor, probably a diode and a capacitor, to take the input voltage that's supplied to these 2 reverse back pins to the right level to work the moving coil mechanism movement. Beautiful. But someone contacted me who wants to make a replica of power, like a power grid, UK power grid analysis that gives readings of all the sources, different sources that we get our energy from, electrical energy, which is a very exciting project, running off an Arduino. 6 of these, each with its own specially engraved face, the legend, as I like to call it now. So I'm going to take them apart. In fact, here's one I took apart earlier. There's the movement. Focus. And they're lovely, these gauges, because they come apart with 2 screws, which I've carefully stored inside, and you can get them all apart. This is a smaller version of the one that I've used in several of my machines. It's lovely. As I say, with the addition of a few, about 2 or 3 components, you can get an Arduino pulse width modulated output to run one of these, with it being 0 sent to the pulse width modulation output there, right up to 255 at this side. And obviously then you can do any calculations you want and run it and get it to show and display anything, temperature, time, you name it, or even power usage on the national grid. Fantastic. I do like putting these circuits together. I'm so pleased, and lots of people who've built the kits have said how thrilled they were to have an opportunity to learn a little bit about how to make an electronic circuit without any special tools. Let me show you. Orange, white, brown, orange, white, brown. And the kit comes with a wire guide, which several people have also said they've subsequently gone on to use when they make their own electronic things. So for example, this resistor, you just bend it round there, snip the wires off. I'm trying to keep it in the viewfinder. And then, where was it? It was there. So you just, there. So you just push the wires in, and push it down. Very satisfying. And this is a little piece of breadboard. So all the connections are made with lots of sort of little spring clips inside. So you don't need to solder or anything, and it holds all the components in place. It's lovely. Well, I've got everything I can done with the net. There's the pump housing assembly with a flickering lamp and bits of copper and stuff, and it's a beautiful polished base which I'm just waiting to dry. So whilst that's drying, I'm going to start working on this. How exciting. First thing I've done is to sand the back of this clock, the main clock housing, and glue on the pieces of raised plastic that will actually have a back on it eventually that will hide the clock movement, because I was thinking it might be sitting on a desk, so you might see the back of it, so the back needs to look really nice as well. And I was thinking, because in the past I'd glued this piece on, and I was thinking, no, gluing is just one way, which is very handy sometimes. I'm going to just screw this all together, because I realised, as I said, this is just decor in effect, and the front of to hide the clock movement to support it, but there's 3 screws down there, there's 4 screws down there, and there's even one in the middle, so that's going to be absolutely perfectly held flat. So that's exciting. And I've sanded the other bits and cut. I haven't got the right M3 screws, these are 25mm, so I've only got 30, so I cut them down and sanded them a bit so I can simulate the actual construction. And I've already worked out several things. As always, it's so difficult. I hate coming up costing things. I really do. I really am. So what I do, I've got my lovely old Griffin and George timer, scientific timer there, that does beautiful. So I time everything I do and keep a log of it all so I can calculate really accurately exactly how much things like this should cost, and then add all the different components and everything. Some people would just be able to think, oh well, that's just charge that much, but I do it because I don't like that, so I do it very, very accurately. Right, let's get this together. Well, that didn't take long. I've hit my first issue, so to speak. Just standing this up, thinking about how best to glue these feet on, and of course it's angled forward because the laser doesn't cut perpendicularly, it cuts at a slight angle, what I said before, because it gets smaller the further through the plastic it cuts. Right, first thing to try is to make this hole slightly smaller by 0.3mm all round, possibly, because it really is very wobbly. I can't show you because I haven't got one hand free, but it is. And I think that will help once this is tight to actually be able to get this set vertically. So I've cut out one that was just too tight. One useful thing with the laser software is that, because then you can say, let's make it 0.1 bigger, and then that's it, there we are. Just made it green for some reason. Let's delete the original one. Now remember, I've done that. Download that, and we'll cut that out. It's really useful. I regularly have to do this, but using that tool is really helpful because I can very quickly establish the exact size that will work when joining two things together. Action! Oh, now I like that. Ooh, that's really nice. That just pushes really nice and firmly. Now if I try and line it up there, that's good. It's so stiff, it's stiff enough for you to be able to just angle it until it's absolutely perfect. But that's what's so enjoyable about this sort of project, this part of the project. Just refining it, seeing opportunities to make it even better, spending the time and effort necessary, and then the satisfaction knowing that is as really good as you can get it to be, sort of, something like that. And look, it's so successful. I've got my plate glass down here simply because it's flat and the table isn't very flat. Any flat surface would do. I've got my right angle thing and it lines up perfectly. It's now stiff enough so I could just bend it a little bit and then drip super glue in the two holes. It's running, it hasn't run around the edge to appear anywhere else. Glued on these two 2mm bits. That's perfect. It's absolutely solid. You can see how the glue has run round. Can you see how the glue has run round? You can see where it's actually joined on both sides. So it's a really, really solid thing. I'm so pleased with that. First problem down. Oh, and look, I've glued the engraving on there, and the purpose of that is it's all going to be painted brass. But one of these small LED lenses, it just, a rebate at the back, look at that, it pushes in. I think I needed to do that because I needed everything flat so that whatever AM and PM sign moving inside didn't bang into it. That is just fabulous, very pleased. And indeed, dear friends, here's the bit on the right, same thing again, look. Once that's sprayed up, putting the gem in, oh joy. And again, the hole in the back, you just drip the glue in. It really is a joy. And again, when I glued this on, all I need to do is to hold it into place and then just drip a couple of bits of glue in there, super glue, and then it's spread out underneath and stuck it perfectly. Oh, it's all coming on, I tells you, all coming on. Right, I think that's probably 20 minutes worth of video. It's funny because I always end up inevitably with at least double the amount I managed to edit it down to, with me waffling on and umming and ahhing and things. I try and keep it to about 20 minutes. I know really successful YouTubers seem to make them about 12 minutes long, but I just like to explain to people how they can achieve things. It's the teacher in me, I suppose. No, it just seems such a shame to miss out on little top tips and ways of doing things. Oh, and there's a little top tip. I had a load of these left over. They're the cable ties after I'd packaged the net thread walls, and I cut them off, and I've got these all over the place. I have to say they make the perfect addition to any workshop. If you've got a spot of super glue and you want to move it around, let's do that. If you've got a spot of super glue and you want to move it around, these make the perfect thing. Little spatula just to move them around. Needless to say, I hadn't put any in the bin, I just left them all over the carpet with invisibility, but thankfully they're not that invisible, so I've got an endless supply of these. They have proved really useful. Another top tip, you heard it here first. Right, thanks very much for watching. Hope to see you next time, when I will be getting parts painted. I think I am going to paint them this time. It's silly not to, because I want this to be a working, not prototype, a finished working proper reciprocating clock. Thanks very much. Please remember to click subscribe and like if you have. Hope to see you next time.